Thank you so much for coming out to the first training session, first part of the training session for the MRWA collector training. So today we'll just be going through the macroinvertebrate procedures, the habitat assessment procedures. Marty will run through the macroinvertebrate identification, and then we'll have a chance for all of you to ask any questions you have. Also, if throughout the presentation, if you come across any questions, please feel free, you can put them in the chat and we can get to them at that time as well. And then if you have any questions that you didn't put in the chat, but you still have, you can ask them during the question portion as well. And then we'll leave off with going over the plan for Saturday and the second part of the training for the in-person sampling down at Marshall Memorial Park. Okay, so to start off, Muskegon River Watershed Assembly works with the Muskegon River Watershed, which drains approximately 2,723 square miles of land. It starts up at the Houghton and Higgins Lakes and goes all the way down to Muskegon Lake and finally draining into Lake Michigan. So in the bottom right, that photo is just the Muskegon River watershed in relation to all the different counties that it flows through. And then the top left photo is actually the watershed, and then all of those white circles are all of MRWA's MyCore monitoring locations we've had over the past almost 20 years of sampling. So as you can see, we've gone trying to get throughout the whole stretch of the Muskegon River watershed and have had quite a few areas that we've been sampling in the past. So aquatic macroinvertebrates, those are small organisms that you can see without a microscope that lack an internal skeletal system and live part or all of their lives in water. And so you might wonder why we collect macroinvertebrates. One reason is they're really good indicators of the stream conditions and stream health. So they spend all of their time in, or most or all of their time in water. And it's really hard for them to necessarily move out of their stream section if it becomes polluted. So they're really good indicators of the health of that stream. Additionally, as macroinvertebrate diversity increases, it indicates a healthier stream. So lots of different macroinvertebrates in an area can tell you that a stream is pretty healthy. And while these the water quality ratings and the type of and quantity of macroinvertebrates in a stream might not necessarily tell you why the stream numbers, why the stream is unhealthy or not, or why it might be a low number versus a high number. It does allow you to kind of probe and ask more questions as to why the stream health is the way it is, and then that going into and doing research on the threats to the bug diversity. So those include sedimentation, habitat loss, and chemical and organic pollution. As macroinvertebrate sampling is also really good for volunteers. They're really easy to sample. They're generally abundant communities in their streams, and it's also a really unique experience. So for those of you who may not have sampled with the MyCore sampling since 2021, MyCore has updated their some of their sampling procedures as well as their scoring for the macroinvertebrates. So starting 2021, we had a new data sheet. So that's what this one to the right is. This photo is the new data sheet. And now orders macroinvertebrates from sensitive to tolerant, with 0, the sensitivity rating of 0 being the least tolerant and most sensitive to pollution, and then a rating of 10 being macroinvertebrates that are most tolerant to pollution and not sensitive to it. So there's only 19 macroinvertebrates that you need to know. It does sound like a lot if you haven't really done this a lot, but there, as Marty will show you, there are some pretty distinct ways to identify some of these different macros. And one of the key factors for, or key components of this new scoring system is that it's very quantity-based, meaning that if you don't have enough specimen or samples that you get during your sampling of a site, it can skew the results to show a healthier site when really it's not as healthy. So that basically just means that you are trying to get at least 100 specimen per sampling time at your site. So if you have less than 30 samples of specimen after your 45 minutes of collecting, that means that your site is probably really degraded, and you'd score that a 10, which is very poor for the stream conditions. If you have less than 60, that is also a problematic stream, and you would score it a 7, so very poor. And then if you have 60 to 100 macroinvertebrates, you don't have a penalty, but you're trying to get over 100 macroinvertebrates per site. So the key takeaway here is you want to get 100 plus macroinvertebrates during your sampling time. However, at the very least, you want to get 60. So now we'll run through the different sampling procedures for the macroinvertebrate sampling. So quickly, some safety guidelines for stream work. Make sure to always keep your collection sites, and you're going to want to move slowly and cautiously through the stream, being aware of any scientific equipment or anything dangerous in the stream, such as rebar or chunks of concrete. And as always, make sure to wear life jackets if appropriate. And then when you're collecting, so collectors will get in water, and they're going to want to be in wadeable water. You don't want it to be too high. And you're going to be sampling for 35 to 45 minutes total over a 300-foot stream section. And you're always going to want to work upstream, heading towards clear water. And this is for visibility purposes, so you can see the different microhabitats you'll be sampling. Not all sites will have all of these microhabitats, but if they are present at your site, you'll want to sample in them. And those microhabitats include riffles, pools, cobbles, aquatic plants, runs, stream margins, leaf packs, undercut banks, and overhanging vegetation and woody debris. And as a collector, you're going to be shuffling, pulling, scraping, dragging, grabbing with hands in your nets in the water, sampling all these different microhabitats. As a collector, you're not stopping to examine your net, and never dump your debris back into the net. That's not their job. So if you got a net full of debris and it looks like there's not any macroinvertebrates in there, don't dump it back in the water. It's the picker's job to decide if they're to find any macroinvertebrates in that net full of debris. So as a collector, you'll bring your debris over to the team on the stream bank for picking. So they can either pick on the stream bank, or you can put your debris into a bucket, and everyone can pick afterwards. And finally, muck is miserable, so minimize your muck mass. So if you're at a site and you need like 1 or 2 netfuls tops of muck sample, and after that you don't have to sample in that area again. It's very hard to dig through and find any macroinvertebrates.
And at the training, these nets are very fine, so they pick up muck quite easily. So for those of you that haven't sampled before, we'll show you some techniques to use to get rid of most of that fine material in muck.
Thank you, Marty, for that addition. Okay, and then as a collector, you're going to be directing your pickers to place their macroinvertebrates into small jars of either 70% ethanol or 70% isopropanol with labels. And then, as you mentioned before, you're trying to get at least 60 creatures. Greater than 100 is preferable. And then as they're picking, they don't need to count how many macroinvertebrates they have, just have a good idea of how many that they're getting throughout their time frame. And then while collectors will be in the water collecting debris for 35 to 45 minutes, pickers can pick for 60 minutes. So say you collect for 45 minutes, your pickers can continue picking for 15 more minutes. And then you will stop and then start identifying what you found. And additionally, a head picker or leader with experience or training is a very helpful person on the stream bank. So then your pickers, make sure that they don't prefer one type of creature over another. You want to make sure to get all the different macroinvertebrates, because like I said before, the greater the macroinvertebrate diversity, the better the stream health. So make sure you're getting everything that you find. Optional, if your pickers pass 150 macroinvertebrates, you can't have them stop. So say you reach the 45-minute mark for picking and you've got 160 macroinvertebrates, you can stop and just identify those 160. You don't have to keep picking for 15 more minutes. And finally, make sure to count and release any clam, mussel, snail, fish, or crayfish. The only exception to this is the New Zealand mud snail, and there's some photos to the right. Also, when you go out, provide collectors and pickers photos of the New Zealand mud snails, because these ones you want to make sure you keep. Make sure pickers let you know that they find them, and then you'll contact an eagle biologist.
I assume they're invasive.
Yes. Another new addition to the procedures in 2021 was decontamination. So now all equipment must be decontaminated with dilute bleach or other chemical like 409 once sampling is complete. I'll play this quick video for y'all to go through the decontamination process, but on Saturday when we do our sampling, we will also walk through this whole process as well, so everyone can have a chance to go through it too. So let me make sure my sound is shared. Can everyone hear that?
Mhm.
Yes.
Yes.
Okay, just want to make sure. Okay, thank you. Just want to make sure before I got too far.
What exactly is an invasive species, you may be wondering? And why is it bad to have them spread? An invasive species is one that is not native and whose introduction is likely to cause harm to Michigan's economy, environment, or human health. Often nicknamed hitchhikers, invasive species can spread by hitching a ride on humans and their equipment. Once in a new location, these animal, plant, and fungi species reproduce rapidly and damage ecosystems, even to the extent of harming human economies or health. Invasive species can outcompete native species for food and habitat, leading to excessive growth and reproduction and loss of ecosystem diversity and function. In other words, invasive species can be really bad, and we want to prevent them from spreading. So once you've wrapped up your important work monitoring the health of our waterways, and it's time to head back home or off to another site, there are a few simple, effective, and critical steps to do first. Inspect, remove, disinfect, and dry. To inspect thoroughly, look closely at all parts of your clothing. Make sure to check the folds and seams where some species may hide. Check your boots or shoes for any signs of hitchhikers that might not belong. And don't forget to inspect all of your gear, especially anything that may have come into contact with the water or shore. Next up, grab your handy decontamination supply bucket and use the tools to remove any debris, mud, animals, or plant matter. You don't have to be able to identify it to remove it. And by doing so, you're making sure not to spread invasive species. Things like seeds or plant matter might be easy to remove, but also make sure to clean off any mud or debris that can contain bacteria or tiny creatures like worms and snails. Tools like lint rollers and brushes and scrapers for boot treads can help make short work of the removal process. Don't forget that you can use the water where you are to help wash, rinse, and discard what you remove. Once you've inspected and removed anything suspicious at the site, head back to your vehicle for the final steps: disinfect and dry. Here, you'll take your bottle of bleach solution and spray the bottoms of your boots, waders, trays, or anything else that has gotten dirty. Make sure to wash your hands and then wait 10 minutes for the disinfecting magic to happen. Keep in mind, you don't want bleach anywhere near the waterway, so please be careful that your vehicle's not by the shore. Spray down your gear again with tap water to get the bleach off. Then towel off and air dry your equipment before using it again in another water body. It may need 2 to 5 days of drying time, depending on the type of invasive species you encountered. Then load up your gear and you're good to go. Thanks for taking care of our lakes, rivers, and streams, keeping invasive species in check.
Okay, so basically, a quick summary of what the process is you inspect equipment in your clothes for any invasives. Then you can rinse them all your stuff off with stream water, and then move everything away from the stream, probably more towards the parking lot or where your car is. We'll spray it all down with bleach, and then spray it down with tap water to rinse the bleach, and then that's the whole process. But like I said, we will go through it together on Saturday as well, and we're also would provide all the decontamination materials as well.
And Sarah, if I could mention something about the New Zealand mud snail, since we had a question. And it's interesting. We all know where it's from because of the name. And it colonized North America or invaded around 1986 or 87, I believe. But it didn't actually get to Michigan until around 2015. And there have been occurrences found in some fairly local watersheds. And one would be the the Manistee River, and another the Pierre Marquette River. And once they do colonize, they spread quite rapidly. And you can see from that picture, they're fairly small. They're usually less than a quarter of an inch. And one of the ways to tell them apart from some of our other native snails is they actually have 5 whorls or 5 spiral sections within their bodies. So it's very likely we'll know it if you see one. And hopefully you don't.
Thank you, Marty. Okay. And then once you do your collecting and your picking, you'll move to identification. So when you identify, don't do identification during your picking except for light education purposes. The goal of your time is to pick. You'll identify after your 60-minute picking time. So an ID expert also needs to confirm or do all identifications. And once you all go through this training, you should all be ID experts. So you'll be able to do that in your groups. And you can do IDing after collection or hold a different event in the following weeks. And then you should not do the official ID in the field. Do not do the official ID on live creatures, and do not have the volunteers only save a few insects of each type. So once again, you'll be putting all the macroinvertebrates you find in jars. That'll unfortunately kind of kill them, but it's okay there, and it wouldn't affect the larger ecosystem populations in the stream. And then don't also save only a couple of each type. Make sure you have all of them, because we also have to save all the samples for at least 5 years, and those are just for our records. And just in case we have to go back and look at a certain sample or a certain site, then we'll have those macroinvertebrates to go back to. And then once again, for the scoring, it's based off of the Hilsenhoff method. So that measures sensitivity to organic pollution from 0 to being not tolerant to 10 being very tolerant. And organic pollution, that's some pollution delivered to a stream through both point and non-point methods. And it's strongly connected to oxygen levels. And it comes from natural, agricultural, and urban sources such as like wastewater, fertilizers and nutrients, and pesticides. Additionally, the scores are secondarily connected to habitat and quality flow. So areas with higher organic pollution will have degraded habitat through land use and development impacts. And that can lead to more bank erosion, fine sediments, and flashy water flows in the area. And then we have the new scoring sheets. So the scoring sheets, once you go through them, it provides a water quality rating, or a WQR. So the sheets over here, they have 5 different columns. You have the count, the common name of the macroinvertebrate, the scientific taxa, the sensitivity rating, and the count time sensitivity. So when you do your identification, you'll be calculating how many macroinvertebrates you have, how many of each macroinvertebrate you have, and you'll record it in the count. So like 1 hellgrammite, 35 caddisflies, etc. And the first step for filling out the sheet is then you will then sum up your total abundance. So the total abundance is basically just adding up everything in the first column, all the counts. So for this one, you'd have 75, and you'll put it at the bottom left at that total abundance box. So that's for step 1. And the next step is to determine the count times sensitivity for each different type of macroinvertebrate. So what that means is you have your count. So like, for example, hellgrammite, you have 1 hellgrammite, and then you have your sensitivity rating. So hellgrammite is very sensitive to pollution. So it has a sensitivity rating of 0. So you would do 1 times 0 and then put it in the far right column, the count times sensitivity column, and for 0. And then you can, for example, for like mayfly, you have 15 mayflies that has a sensitivity rating of 3.5. So 15 times 3.5 is 52.5. And then at the bottom, you have like leeches, you have 3 leeches, sensitivity rating of 10, 3 times 10 is 30. So you go through and calculate the count time sensitivity rating for every macroinvertebrate species that you have found. And then the next step is to then sum all of those up as well. So you'll take all of the numbers you have in that fifth column, the count time sensitivity column, add them up. And at the bottom, there's a box towards like the middle, the sum of count time sensitivity. So add up all of that fifth column and you get 335.5. And then the last step is to finally determine your water quality rating, or WQR. So you just take the sum of the count time sensitivity and then divide it by your total abundance. So for this situation, the sum of count time sensitivity is 335.5. You'll take that value and divide it by the total abundance, which is 75. So 335.5 divided by 75 is 4.47. And that is your quantitative water quality rating. And then there's this chart to the right, this lovely rainbow chart that you can use that to determine your degree of organic pollution and the qualitative rating for your score. So for 4.47, that'll fall between 3.51 and 4.5. So the very good section. So that has slight pollution possible for this example. And then, as I mentioned at the very beginning, if you have less than 30 total macroinvertebrates, so if your total abundance is 30 or less, you'd automatically give it a water quality rating of 10, which is very poor. And then if you have less than 60 for your total abundance, you want to automatically give it a rating of 7, which would be a fairly poor rating. So regardless of, that's why I had mentioned that this scoring is dependent on the quantity, because you could have 30 here and they could all be in the top portion of the charts, the 0 to 5 sensitivity rating, and you might have then you'll get a water quality rating of like excellent, but you only have a small sample size, so it could be misleading. So that's why it's important to get at least 60, but shooting for over 100 of your different macroinvertebrates for each sampling.
Sarah,
And
can
then,
I also add,
oh yes, yeah,
that people need to work as fast as they can because that time runs out really quickly.
yeah.
they're
So
picking.
the full 45 minutes of collecting, you're collecting the whole time. The full 60 minutes of picking, you're picking the whole time to make sure you can get that minimum of 60, shooting for 100 of those specimens. And then for MyCore, they do allow some variation in procedures and logistics, but some things you have to keep the same for everyone. So one thing is collectors must be trained ahead of time with practice sampling session, which is what you all are doing right now. Everyone must also follow MyCore collection procedures, and that is, as previously mentioned, 35 to 45 minutes of total collection time over 300-foot stream sections, and picking for only at max an hour to get all your macroinvertebrates. Additionally, all macros must be collected in a 2-week window that is similar year after year. And we already do that when we set up our official sampling. So we usually do our official samplings in mid-May. So we do that every year at MRWA. And then finally, don't do your official IDs out in the field. Kill the specimen in alcohol, ID in a controlled setting with an expert, and make sure to keep all your specimen. And then that was the end of the macroinvertebrate sampling. So I'll quickly run through a habitat assessment. So like everything else that I'm talking about today, we will run through this during our Saturday training. And the habitat assessment helps us understand why we are finding these macroinvertebrates or why their populations are changing. So it's a qualitative assessment, not a quantitative. So the macroinvertebrate sampling is a quantitative assessment, but the habitat assessment is a qualitative one. And your team will fill out a form answering questions on stream size, flow, presence of foam, oil or trash, stream bank conditions, plant communities, size and condition of riparian zones, sources of degradation, and an optional pebble count. And then a habitat assessment occurs once every 5 years. So when we all go out to do the official sampling in May, You will do a habitat assessment for your sites, but if you sample with us again on these sites in the fall or next spring, you'll have to do a habitat assessment again for another 5 years. When to hold it after collecting macroinvertebrates, you're going to want to know what your habitat looks like. And so it's best to do it after you do your macroinvertebrate collection, because at that point, you've already been looking, been in your stream and looking at the habitat for at least an hour. And it's also good to do it in the summer or like during a spring sampling, because it's dependent on vegetation types and density. And then how you go through it is the group needs to spend some time at the stream before answering the habitat questions. That's why it's good to do it after the macroinvertebrate sampling. Then you have one person will walk the group through the data sheet, while the rest by consensus rates different aspects of the habitat. And you'll try to come to an agreement on everything, but if there are some things you can't agree on, you can take averages with the ones that have numbers, or you can also record comments. Okay, so now I'm gonna hand it over to Marty Holtgren to do the macroinvertebrate identification. Me. Okay, you're good to go, Marty.
Thank you. Sorry, are you able to see my screen?
Yes.
Okay, thank you. I have the exciting job. I get to go through in 15 minutes the exciting world of macroinvertebrates. And I did want to let all of you know before we go into this, there's 19 different types of insects that you need to key out. Don't get intimidated by that, because, and I know, John, you've been out there a lot too. Once you get into it, I bet you in a half an hour, you're starting to pick it up pretty well. Second time you're out there, you feel confident. Third time you're out there, you are an entomologist. So it comes together pretty quickly. So in the next few minutes, I was just going to go through some of the major groups that we'll be looking at and discussing some of the different parts of the macroinvertebrates that really help to look at, because as we go through the keys, that is what we use to make our decisions. Now, obviously, the most easiest of any insect is to look at the head part. So this is the first of three major parts of macroinvertebrates. You also have this thorax section, and on many of the insects, you actually will see these three segments in the thorax. And then you get to the abdominal part, and it's actually pretty fascinating. Sometimes you'll see hooks, you'll see tails, you'll see gills. So all of these different body parts have features that make ID, fairly simple to do. Now, I don't want you to look at the details on this, but we're going to be providing you with a key, and it's a dichotomous key. And usually the decisions are fairly straightforward, and it's a yes or no. And I always figured that I was extremely lucky if I got a hemiptera up here, because I only had to make one decision. So some of them you have to go through maybe 5 or 6 decision-making pieces. The first, we're going to go through those different groups, and the first one I'd like to talk about is the order of Megaloptera. And these are very, very interesting creatures, and we'll find 2 different families within the rivers that we're going to be sampling. These 2 families, one is the Hellgrammite, and the other is called the Elderfly. And you can tell from here on this little band, both of these are very sensitive to pollution. So they're very good indicators of a healthy stream, in fact, quite a healthy stream. Probably the easiest piece when you're looking for a Hellgrammite, they have these, especially the Dobson fly, they have these projections that stick out. They're often fairly large and often found attached to wood. So if you're using your net and probing the wood, there's a chance that you'll be able to dislodge one of these. The other piece, they have this called a proleg or prolegs back here. And these are known, they actually can grasp onto wood with these prolegs to keep them there. Now, I rarely give warnings about insects, but this is one I've never personally been bit by, Helgermite, but there is that risk. They are known to be a little grumpy and take a bite.
This
The
time of
second
year,
one-
they should be pretty small though, right?
You know what? You're exactly
No.
right. There's some they can overwinter. I guess our hope could be that the cold water makes them move a little slower.
How big are they?
The second one here, it has a similar body shape and it's got advanced mouth parts, but the major difference here is when you look at the proleg section back here, that it almost looks like a gill, and it's quite distinctive from the Helgermite. So the next we're going to go to one that probably many of you are familiar with, at least at its adult stage here, and that is the stoneflies. And probably one of the most distinctive pieces of the stoneflies is they have two tails, and where mayflies would have three. And you sometimes can see gills if you flip the specimen over, and those gills are tucked up near the abdomen. And those are often found in gravel or on cobble. And let me see here. Oh, I wanted to show you we don't have my favorite one. Okay, so I'll go to the next slide, which is one that probably many of you are familiar with as well. And they're caddisflies. And these are also sensitive to pollution. And the interesting piece about caddisflies, although they have 3 pairs of legs, you won't always see them because they make, many of them make beautiful structures that protect their bodies. And this one you can see like little pieces of debris and rocks and wood that have put together the case. Some actually form a case with sand. So if you do see a little a kind of elongated pack full of wood, structure, take a look at it. And if you pick it up, it might pop its head out. And that happens frequently when you see the head pop out in the front arms.
And there's little tiny caddises, and there's caddises that are bigger.
And then, and that's right, I heard the comments, some caddis get quite big, which we may see. If you see one that does not have the protective piece here, you can look at its body, at its thorax, and it'll have 3 plates. And if you see that, these really defining plates, that's likely a caddisfly. And then finally, they have this really pretty section of proleg here that fans out. And there are some similarities. I'll actually get into that in a moment. The other one is the order MRWA, which is the mayflies. And these have 3 tails. So that's how you can distinguish those between the stoneflies. And really they have some beautiful feathery gills that are on their bodies. For those of you that have seen the Hexagenia mayfly, on this back section here, if you see them in the water, those gills are actually waving in the water current. They're picking up oxygen. And I'll give you my bias here. There's another 3-tailed mayfly. It's called the flat-headed mayfly, and it's pretty cool. It's got a broad head, and that flat head holds against rocks. And then finally, this is called the small minnow mayfly because it does look like a small minnow when you see it swimming. Another common that we'll likely see is the dragonfly, or I should say the order Odinate. And one of those in that order, or suborder, is the dragonfly. These are quite easy to determine. One is they have this stout body. They have what's called this labium mask to catch their prey. Actually, if you stick your fingernail underneath it and you pull down on the mouth, it extends out like a 1/4 inch. And you think, well, why does it do that? So when it becomes terrestrial and goes airborne, if any of you have ever seen them eat a mosquito, you see that labium expand, and it's like this shovel that pops out and it eats their prey. So it's a very good defining characteristic for this organism. Also have very large eyes, and at the point, they have these little 5 stiff points that come out of the abdomen. And you don't have to worry about the dragonfly because they are not biters and won't hurt. So even though it looks like it could. Another in that same family, the odonate family, it's a suborder, and it's the damselflies. And these are interesting because they share some characteristics with other families, such as the mayfly. If you look, they have these three tails, and I'll get into a minute how you distinguish between them. And they have broad heads and pretty obvious eyes. You think, well, how can I tell the difference between a damselfly and a mayfly? Here's the two side by side. And the damselfly, they don't have the gills on the abdomen like you can see here. And on mayflies, those are usually quite distinct. The other piece is that you can see at the very bottom, these flare out a little more than the mayfly gills, or what I'll call them, usually do. So you're usually able, just from looking at the gills on the abdomen, if you see those, it's not a damselfly. Then we get to the beetles, and these are one that many of you have probably seen, like the whirligig beetle or the water scavenger beetle. You'll see them on the surface. They generally have these hard bodies, or the hard wing shields, and they're oval shaped. They also have well-developed eyes, and many times that you'll actually see them in slower flowing water and also in vegetation. The beetle larvae, though, however, look extremely different. I should mention this is kind of a transitional species or group, because it's this 5.1 sensitivity. So they're kind of right in the middle of what they indicate. Now, the beetle larvae look extremely different than the adults. And the eye spots, they're usually still visible, and you can see the mandible parts at the mouth. And they also sometimes have some lateral, appendages coming off the body here. And in the key, it'll be fairly distinctive that it's a beetle larvae. With that said, there is some confusion. I'm not going to go into this today, but we'll talk about it a little when we're at our training, that the beetles can be confused with their alder flies and also with the Dobson flies. So there's some key characteristics we'll go through, and we actually have a key that just by making a few simple decisions, we can tell which of these three larvae that the organism is, and we can go through that on site. There's also another confusion piece, and that's between the caddisfly and beetle larvae. Now you can see, like I'd mentioned before, there's these three hard plates that are usually on this thoracic region of the caddisfly. The other piece is they have these two pretty predominant hooks. And you can see those fairly well right here. Versus the beetle larvae, which they have multiple, double the hooks, and they have 4 hooks on that proleg. So that'll be one of those characteristics that we'll look for. Get near the end here, but we're getting to one of the pieces which is changed. And there's actually now 3 different categories for this Diptera order, or the true fly order. And I bet you most of you will recognize at least the adults of some of these species in the order true flies. And from here, you can see their body shape. Most of them are pretty similar. They're these soft-bodied, worm-like creatures. They also do not have legs, and they do not have visible wing pads. And sometimes it's even difficult to determine where their head is. So those are pretty good defining characteristics for this order of the true fly. And as I mentioned, the reason they did this break is that the sensitivities between the fly groups, it varies tremendously. From these true flies, which are extremely sensitive with a sensitivity rating of 1, and then you get in the middle of the somewhat sensitive flies, and then you have a third, which is your very tolerant. And because you can guess your mosquitoes and your maggots, those are tolerant. So go through those in just a moment. So these are, to me, absolutely fascinating, and they're fairly simple. In the sensitive group, you have one called the water snipe. And this one's found in fast flowing water, and sometimes they're green, but this is one of those examples of one that I believe it's kind of hard to tell what the head is. And it is very distinguishable. And it's also interesting. This one sometimes will float. Sorry, that's my beagle barking. Sometimes will float within the sample. The second one is this very distinctive net-winged midge, and it is known for these suction cups on its body. And Pat, I don't know if I've ever seen a net-winged midge before in our samples. And the final one is a Dixid midge. And the characteristics of this, you can see the prolegs with hooks, but it has this interesting flattened surface that's here. And this one certainly floats on the top of the water when you're going to be picking. So we go from these super sensitive to, oh, I guess I skipped these three. We skipped to the very tolerant, the 8.7. Did I miss a slide, Sarah? I don't think I did. Nope, sorry. You get to the mosquitoes, they always have a very well-developed head capsule. And there's something called the soldier fly, which has almost leech-like in its look. It has a flattened body with a leathery look. This one's often found in mud. And then the final is the rat-tailed maggot, or the hoverfly, and either name is not very becoming. And on this one, you cannot see the head. And you will, though, see these little mouth hooks if you look close enough. So the sensitivity rating, again, it's pretty amazing for these different fly larvae from 1 to 8.6. So what does all this mean? As we get into it, I wanted to show you a couple of the somewhat sensitives. The first is a black fly, and these are very typically pretty small, but they have a bowling pin shape. It's pretty incredible, and you'll see these filter fans at the head. The second one is the midge, and you'll always see the head exposed. These are called chironomids. Sturgeon love to eat them, and you have these prolegs. And to me, one of the most distinguishing characteristics of a midge, one, it can be red, but the other is it comes in this C shape, and they're often curled up when you'll see them. Oh, and the crane fly, the type Hulid, this one by full disclosure is a weird organism, and it's really pudgy. It looks like almost like a grub, and they're typically found in leaf packs, and you can't see the head. One more here. Then we have the true bugs, and these are not incredibly sensitive at a 7.7, but these are absolutely fascinating, the hemipterans. Many of these are probably you've seen before, like with the back swimmers and the water boatmen. Those will be on the surface. All of these have these piercing, sucking mouth parts, and that's what really makes them unique and easy to key out as well. And their wings are hard near the base, but they get more membranous as you get away from the base. And the interesting piece is, unlike many of the larvae, is that the adults look the same as the young. And it's absolutely incredible. You can see these little giant water bugs, which aren't giant, they're little, that are about 1/4 inch, and then they turn into these 4-inch insects. And I must admit that the giant water bug is my favorite of all of them. And they get about 4 inches long, and I've actually seen them eat frogs before, where they had the little proboscises, or the piercing mouth parts attached to a frog, and there's a numbing. Anyway, it's interesting. This one, probably many of you have seen. This is the amphipod, or the scud. We call it a freshwater shrimp or a side swimmer because it swims on its side in the collection tray. And they're very distinctive. There's 2 long antennae, and they have 7 pairs of legs. And we call them compressed or flattened laterally, so they're very, very narrow. We also have in the isopod order what's called a sow bug, probably one that you may have seen as well. And these are very flattened dorsally or ventrally, so they can really hug to the bottom well. And once again, these have 2 pairs of antenna and 7 pairs of legs. So that's one of the
Is
characteristics.
that the same as a roly-poly?
Yes, thank you. They're very.
They're found on,
I probably have some books with good photographs.
you know,
This would be the
they're
aquatic,
like, not in the water.
right? This would be like an aquatic version of those. They're closely
So
related.
they're okay,
They are different species,
okay,
but they have the same common name,
right.
which is confusing.
You know what some books are, right? Some books you see all over here.
Another is the crayfish, which is kind of moderate in its sensitivity. And I don't think I need to go through this with you because you all know what crayfish are. You can see this one has the little rusty patches here, indicating that this one
Those
is
are invasive, aren't they? The rusty ones?
exactly. Those are
Just leave
invasive.
them alone.
Yeah, they're all over, and we typically would just leave them where they are and just count them and put them back. And on the data sheet, if you do see one, write it down as a rusty crayfish, and that helps us kind of identify where they're distributed. But they're pretty much throughout the entire watershed. Also, we'll be working with clams and freshwater mussels. So if you do find these, go ahead and collect them, but you don't need to, you count them, but don't collect them. And we'll put those back because they are very old. They grow slow and their natural reproduction is not extremely fast. So in these conditions, they also often get outcompeted by other, some of the invasive mussels within the watershed too. And some, just to be careful looking that some of these are really tiny as well. Like we talked about the New Zealand mud snail, that one is quite tiny. So it's just, take a close look. Now, if you see something really tiny and black that kind of looks like a snail, look close and it actually may be a midge because of a lot of the midges will attach to rocks. So that's one thing to pay attention to. And then we have various snails. Once again, you won't be collecting those, but do count them. One that we will keep is the zebra mussel and keep those out of the systems that we find them in. So go ahead and you can put those in a collection vial and we'll hold those off. Also, obviously, if you do believe that you've seen a mud snail, and here's pictures of those, you can contact Paul Steen, but I would say that go ahead and just contact us and we can take care of that for you. We'll probably get a photo from you and the specimen, but we can do that. And then the last two are fun ones. Is the leech is the first and easy to ID because they'll usually, if not always, stick to the bottom of your sampling tray. And they have these really cool striations that go across the entire body. And they have a sucker on the front and the back. And you'll often see them crawling on the tray with those suckers where their back will arch and they'll start moving a little bit. So these are extremely tolerant and they're the highest in the tolerance rating at 10. And then another high tolerant organism is the aquatic worm. And these are I find it simple to, they're the longest that we'll see. They're also segmented and they're often pretty clear, or you can actually see through some of these aquatic worms. And they actually look like very similar to just your standard red worm. So you won't have any problem IDing those. So Sarah, I'm going to hand it back to you and we can see if we have any questions.
Yeah, thanks, Marty. Does anyone have any questions on anything that they've learned today?
For the Saturday training, do we need to bring waiters?
Yeah, I was that's something I was gonna cover at the end, but if you have waiters, you can bring them. If you do not, we do have some at our office. So just email me. I have Marty, can you give me back the control of the, oh, actually, I got it. Okay. One moment. I can share that slide with my information as well. One second. Basically, yeah, if you have waiters, feel free to bring them. If not, email me with preferably tomorrow or the next day, and with your boot size as well, and we will we can provide them too.
Sarah.
Yes.
Sarah, they should email you by tomorrow because we're going to be packing and loading tomorrow, remember? And we won't be back.
Yeah,
at the
if you can
office.
email me by tomorrow, that would be awesome. But just, yeah, that you need them and what boot size you would like.
Yeah.
Oh, and then someone asked, who's responsible for keeping track of time during the sampling? What would you, Marty or Pat, what would you say for that?
I usually have had Pat keep the time, and when I'll be out on the stream collecting and she'll be picking, I think it's easy for the person out in the stream to kind of lose track of time. So I would suggest it's a good question that someone, and that's defined beforehand. So Pat and I would have, talked, and she would keep track of time. So that's what I'd recommend, is that one of the pickers is actually the one keeping the time.
Any other questions at the moment?
Where is that location? I can look it up, but in general, where is it?
Yeah, here, let me put my last slide up for y'all to see. Okay, so yeah, so our next training session will be at Marshall Memorial Park. That's, oh, can you all see this yet?
No.
No.
Oh, now it is. Okay, it said it was
There
loading.
you go.
Okay, there we go. Sorry about that. Next training session is at Marshall Memorial Park in Newaygo, and that's at 246 State Road, Newaygo, Michigan. That's from 10 a.m. to 1 p.m. We'll be meeting in the parking lot. Things you need to bring, water. I had written this originally last week when it was sunny out, but I guess sunscreen is applicable, but probably more warmer clothes. Bug spray. Bring your own waders if you have them. If not, like I said, email me by tomorrow with your boot size and I can supply them. My email, if you do not have it, is at the bottom, sarahkresman@ferris.edu. And also there's a little bit of walking to get out to the section of the stream that we'll be sampling at. So make sure you have some good walking or hiking shoes. And then I'll also add that, so this is our training on Saturday. Our official sampling, which you all will be trained for to be collectors, would be May 20th. That's a Saturday. And that's gonna be from 11 a.m. to 2 p.m. And right now the plan is to meet at Ed Henning Park in Newaygo. And from there, we have two sites that are very close to that park that we will want to be sampling to do our to start getting some data for our MyCore database. And that's at the Wheeler Drain in Grant, Michigan. It's about like 10 minutes away from Ed Henning Park, and then also Brooks Creek, which is where we'll be sampling at on Saturday. So does that answer your question about where it's at? Did you need a better description? Or
You only sample those two sites?
so those are the two sites that we need extra help for sampling. And at each of those sites, though, there's at Wheeler Drain, there's 3 separate sites throughout the stretch that we'll be sampling at. And then Brooks Creek, there's 2 separate locations that we'll be sampling at.
Okay.
So it's 2 locations, but with a total of 5 actually sampling sites.
I think last year we had almost 20 sampling sites, so a pretty large number. And this year we won't have quite as many, but we'll still be doing around 10 different sites with your help. So it'll still be a good year. And I should mention too that the sites that you are collecting from, we're making summary sheets. So once you collect your data, we'll process it, and then in a couple of months we'll be sending you what the data tells us, and we'll incorporate all of the historic data as well, because we appreciate what you're doing for us, and we want you to see how it's being used and benefiting the watershed. And I should mention, if you haven't been to Marsh Memorial Park, it doesn't matter which way you're approaching Newego. If you keep driving, you'll get there. It's right on the main street or on State Street. It's basically just southwest of the city of Newego, from the downtown Newego.
Isn't it next door to the funeral home? I think
Yes.
the funeral home's next door.
Yep.
It's a beautiful site, and the two Brooks Creek sites are, we have a lot of history sampling those. The Grant sites are new, but we have a lot of history sampling the Brooks Creek sites.
Yeah, I will add that the sites that we do sample, especially the sites we're sampling this year, even though it's fewer than in previous years, they're all sites that we have sampled for long periods of time, like, you know, some of the sites like 10, 15 years. The other sites we are sampling at are areas that either have planned like restoration for it or have done restoration previously. So it's helpful to do MyCore monitoring in those areas as well to see if there's any changes in the water quality during these restoration periods or afterwards. Any other questions at all?
Nope.
Nope. All right, well, I want to thank you all so much for coming out and joining us on this Tuesday evening. If you have any other questions before Saturday, please feel free to email me. And then I'll be sending out an email that'll provide all of the PowerPoint slides that you all just saw, so you can feel free to look at them again, do some more review for your identification, as well as a link to this recording as well, if there is anything that you missed and want to get a review of again as well.